Here's another function here on my YouTube channel. Now you have exponential functions as well. The parent function is e to the x. Make sure you understand the distinction between e to the x and x squared. X squared is what they call a power function. This one, however, is exponential. Now, there is a rule for exponentials. It can be derived, but just for right now, for the purpose of understanding chain rule, just understand that the derivative of an exponential, you can derive that the derivative is actually itself. Now, there are a few other rules you could consider. If you had the derivative of ax, it's going to be like the generalized power rule. You take the derivative of ax and you multiply it by the exponential. If you want the derivative of any function, multiply the exponential by the derivative of u, which is either u prime or du with respect to x. So those are all rules associated with the exponential. And remember, you don't use the power rule on anything exponential. So one example that I often see in Business Cal, and you might be able to relate to it here too, like let's say you wanted to know not just the derivative, but you also wanted to know f prime of 10. Now in Business Cal, they often mean this as growth in the 11th year, which you have to use the derivative at 10 to determine the growth over the next year and make projections. So let's use the exponential rule. If you follow the model to the letter, you multiply, you take 9% of the exponential, because the derivative of 9% of x is just 9%. You can do some simplifying. And that would be the answer if we simplify. 9% of 1,000 is 90, and then you multiply by the exponential. Now, if I wanted to find f prime of 10, I need a calculator. And while I'm busy letting the camera run, I'm looking for my calculator. So if I wanted f prime of 10, it's going to be 90 times e to the 0.09 times 10. I'll put that in the calculator. And what's going to happen is in the calculator, I'm going to get $221. You'll find out that that actually represents the growth of this particular bank account in the 11th year. So that was an example of an exponential. Now things could get a little more complicated and you might have exponential raised to an actual function. Those don't happen very often. But like, for instance, if you ran into one of those, like let's say you had e raised to the x squared minus 4. Yeah, you're ever going to see that. The derivative of that would be the exponential itself times the derivative of x squared plus 4. And that would be equal to 2x times the exponential. And if you have other bases, like for instance, let's say you had 2 to the x, what you're going to find out is you would have to adjust any base other than e by a logarithm expression. And it would be the logarithm of the base. if this was like 4 to the x, the answer would be 4 to the x times natural log of 4. Now, if you had something like a function up there, you would also multiply by the derivative of the function. But we don't do too many of these examples, however. One thing you do have to realize also when you do exponentials, and you want to take a derivative, don't ever multiply 30 by 2. The 30 stays in front as a constant factor. So anyway, I blurred a few examples by you. Make sure you take a few good notes. And thank you for tuning in. Remember, you can always play these videos slower. There's a setting on YouTube.